There is a refrigerator that runs on a single candle flame, no compressor, no electricity, and no moving parts whatsoever. Just a small flame heating a sealed loop of ammonia, water, and hydrogen gas. Swedish students invented it in 1922, and Albert Einstein patented an improved version. By 1956, it was gone. By the end of this video, you will discover exactly why the most powerful appliance companies in America killed it. Before we get into it, if you want to learn how to set up your own off-grid power systems, go check out my buddy Oliver over at Off-Grid Ohms with Oliver. Trust me, he is breaking down stuff most electricians will not show you. The idea that heat can create cold sounds like a contradiction, but it is measured, documented thermodynamics that scientists have understood for 200 years. In 1824, a British scientist named Michael Faraday was conducting experiments to liquefy gases in his London laboratory. Among those gases was ammonia. Faraday discovered that when ammonia evaporates, it absorbs an enormous amount of heat from its surroundings. The temperature plummets. That single observation is the foundation of everything that follows. 34 years later, in 1858, a French engineer named Ferdinand Carré built the first functional absorption refrigerator. His machine used water and ammonia in a sealed system. No pump, no piston, no moving parts. A flame-heated ammonia dissolved in water. The ammonia boiled off as gas, rose into a condenser where it cooled back into liquid, then flowed into an evaporator. There, it rapidly expanded and absorbed heat from the chamber around it. The temperature inside dropped below freezing. The ammonia then recombined with water and the whole cycle started over. An endless loop of cold powered by nothing but a flame. Carr's invention found its first major success during the American Civil War. Union naval blockades had cut off the natural ice supply from northern lakes. Confederate states in Texas and Louisiana desperately needed cold storage for food and medical supplies. Carr's absorption machines made ice in the blazing southern heat without electricity, because electricity did not yet exist in any practical form. Here is how simple the physics really is. Ammonia dissolves in water. Heat that solution and the ammonia boils off as a gas. That gas rises into a condenser and cools back to liquid. Let that liquid ammonia flow into a chamber filled with hydrogen gas. In the presence of hydrogen, the ammonia evaporates rapidly. Evaporation absorbs heat. The chamber gets cold. Cold enough to freeze water, cold enough to preserve food for weeks. The ammonia and hydrogen mixture flows back down into a reservoir where water recaptures the ammonia. The cycle repeats endlessly. Gravity and thermodynamics do all the work. The only energy input is a small, steady flame. The system is quiet because there is no compressor vibrating on your kitchen floor. It is dependable because there are no mechanical parts to wear out. It runs on propane, natural gas, kerosene, or even focused sunlight. Any source of heat will do. This physics was proven in 1824. By 1922, two Swedish engineering students would turn it into a machine that changed the world, and then the world decided to forget it. In 1922, at the Royal Institute of Technology in Stockholm, two young men, Baltzar von Platen and Carl Munters, were supposed to be attending lectures. Instead, they rented a room together and worked long, obsessive hours on a radical idea. They wanted to build a household refrigerator that would operate without any pump at all. No moving parts, just heat in and cold out. They based their design on Ferdinand Carr's absorption principles from 6 decades earlier, but they added a critical third fluid, hydrogen gas. This was the breakthrough that changed everything. By introducing hydrogen into the evaporator, they created a system where ammonia could evaporate at low pressure without any mechanical assistance whatsoever. Circulation happened through thermosiphon effects and density-driven diffusion. The whole system ran in perfect silence. In early tests at their Stockholm workshop, the evaporator chamber reached temperatures as low as -40 degrees Celsius, cold enough to freeze mercury. Manufacturing began almost immediately. In 1923, the Swedish company AB Arctic started building production units. By 1925, the design was refined enough that Electrolux, one of the largest appliance companies in Europe, purchased the entire operation. The absorption refrigerator had arrived as a commercial product. But the real story for American homes starts in 1925 when a company called Servel purchased the United States manufacturing rights to the Platen Munters design. Servel built a massive factory in Evansville, Indiana. The plant covered 1.5 million square feet of production floor. The new gas refrigerator entered the American market in 1926. By 1927, Servel became the sole gas refrigerator manufacturer in the entire country. For nearly 30 years, no other company even tried to compete. Picture a gleaming white refrigerator in a 1930s American kitchen. No hum, no vibration, a tiny blue flame flickering behind a lower panel, food cold, ice frozen, the electric bill unchanged because no electricity was involved. This was the Servel. The company boasted that only their gas refrigerator stays silent and lasts longer because it has no moving parts in its freezing system. A machine built to outlast the family that bought it. It should have become the standard for every home in America. Instead, it would meet a man named Thomas Midgley, and Thomas Midgley would change everything. From 1927 until 1956, Servel remained the only American manufacturer of gas refrigerators, and those machines were built to last generations. Heavy gauge steel, overbuilt sealed systems designed to run for 50 years without a single repair. When you compare a Servel from the 1930s to the plastic and thin metal refrigerators rolling off assembly lines today, the difference is almost embarrassing. Refrigeration was still relatively new to the mass consumer market, and these gas-powered units became enormously popular in a country where many homes lacked reliable electricity. Rural families across the American South and Midwest, farming communities on the Great Plains, ranches in Texas and Montana where the nearest power line sat miles away. For all of them, the Servel was not a luxury. It was the only option that worked. The machine asked almost nothing of its owner. No maintenance schedule, no compressor replacements, no refrigerant recharges, a small flame and a tank of propane. That was the entire operating cost. Families bought a Servel in 1938 and their grandchildren were still using it in 1985. 50 years of continuous operation from a machine with zero moving parts. Servel was ambitious beyond the kitchen too. In 1939, the company exhibited a residential gas-powered air conditioner at the New York World's Fair. The same absorption principles that cooled food could cool entire homes. No compressor, no electrical load, just a flame and the physics of ammonia. Then the Second World War arrived, and Servel converted its massive Evansville factory to military production. Workers who had assembled refrigerators now built wings for P-47 Thunderbolt fighter aircraft alongside Chrysler and other defense contractors in the city. After the war ended, Servel returned to consumer products and the future looked bright. But while Servel was building refrigerators that lasted a lifetime, General Motors was funding a chemist who would invent two of the most destructive compounds in human history. The first was leaded gasoline, the second would kill the gas refrigerator forever. Before we get to the killing blow, we need to talk about Albert Einstein, because even the greatest physicist who ever lived saw the value in this technology and tried to make it better. In 1926, newspapers across Berlin reported a devastating story. An entire family had died in their sleep from toxic gas fumes leaking through their apartment. The cause was a broken seal on their mechanical compressor refrigerator. In the 1920s, these machines used dangerous chemicals as refrigerants: methyl chloride, sulfur dioxide, ammonia under dangerous pressure behind gaskets that could crack without warning. When those seals failed, the chemicals seeped silently into bedrooms. Einstein read the newspaper reports and was deeply affected. He told his former student Leo Szilard that there had to be a better design, a refrigerator with no mechanical seals to fail, no pressurized joints to crack, no way for toxic chemicals to escape into a sleeping family's home. The two began collaborating immediately in a cramped Berlin workshop. What they designed was an absorption refrigerator operating at constant pressure throughout the entire system. No moving parts, only a heat source required. Einstein and Szilard filed more than 45 patent applications across 6 countries. Their most promising design received a United States patent on November 11, 1930. Engineers who examined the blueprints estimated the sealed system could last 100 years because there was simply nothing inside that could mechanically wear out. In 1931, Einstein traveled to the United States and personally tried to find an American manufacturer willing to produce his refrigerator. He shopped the invention to company after company. Nobody bought it. The timing could not have been worse. The most promising of the patents were quietly purchased by Electrolux in Sweden and placed on a shelf to gather dust. 45 patents from the mind of Albert Einstein, 0 consumer products. The greatest physicist of the 20th century designed a refrigerator that could run for a century on a candle flame, and nobody in America wanted to build it. The reason had nothing to do with technical failure. Something else had already captured the market, a compound called Freon, and the man who created it was already drawing a paycheck from General Motors. At the end of World War I, General Motors had purchased the Frigidaire Corporation. It was not immediately profitable. In 1921, Frigidaire lost $2.5 million, a disastrous year when only 5,000 refrigerators were manufactured in the entire United States, of which just 365 were Frigidaires. Charles Kettering, the head of research at General Motors, understood that finding a better refrigerant would determine whether Frigidaire survived or died. He assigned the problem to a chemist named Thomas Midgley Jr. Midgley was already famous inside General Motors for adding tetraethyl lead to gasoline, a decision that would go on to poison hundreds of millions of people. Now, Midgley turned his chemical expertise to refrigeration. In 1930, Midgley stood before a packed audience at the American Chemical Society and performed a theatrical demonstration. He inhaled a deep lungful of his new synthetic compound, then exhaled it directly onto a burning candle. The flame went out. The compound was neither toxic to breathe nor flammable. He called it Freon. Within a single year of that demonstration, Freon was being manufactured and shipped to Frigidaire and to virtually every other major refrigerator maker in America. It became the universal industry standard almost overnight, and it did something devastating to the gas refrigerator. Before Freon, the biggest selling point of the Servel absorption fridge was safety. Compressor refrigerators leaked deadly chemicals. Families died in their sleep. The Servel had no mechanical seals to rupture, no pressurized gases waiting to escape. It was marketed as the safe choice, and that marketing was true. Freon eliminated that argument in a single breath. Suddenly, compressor refrigerators were safe too. The entire foundation of Servel's competitive advantage evaporated in one dramatic chemical demonstration at an industry conference. Here is what nobody in that audience knew. Freon was a chlorofluorocarbon. It would take 5 decades for atmospheric scientists to discover that chlorofluorocarbons were systematically shredding the ozone layer above Antarctica. The Montreal Protocol of 1987 eventually banned them worldwide. The miracle compound that killed the gas refrigerator turned out to be one of the most environmentally catastrophic substances ever manufactured by human hands. Environmental historian J.R. McNeil would later observe that Thomas Midgley had more adverse impact on the atmosphere than any other single organism in Earth's history: leaded gasoline and Freon. Both from the same man, both bankrolled by General Motors. The Servel absorption system used plain ammonia. Ammonia does not destroy ozone. Ammonia does not warm the planet. Ammonia does not persist in the upper atmosphere for decades. The technology General Motors crushed was the cleaner one all along. Freon was the bullet, but General Motors pulled the trigger with something far more powerful than chemistry. They used money and policy and the entire American electrical grid as weapons. The death of the gas refrigerator was not a single moment. It was a systematic campaign, waged across multiple fronts over 2 decades. Start with federal policy. During the New Deal era, the Roosevelt administration created the Electric Home and Farm Authority. This government agency provided low-cost, taxpayer-backed financing so American families could buy electric appliances, refrigerators, washing machines, stoves, all electric. Gas refrigerators were explicitly excluded from the program. If you wanted a subsidized appliance loan, it had to be an electric appliance. Millions of families who might have chosen a Servel were instead steered toward Frigidaire and General Motors by the financial incentives of their own government. Then came the branding war. The name Frigidaire, backed by the General Motors marketing budget, became so dominant in American culture that millions of people began calling every refrigerator a Frigidaire, regardless of who manufactured it. Linguists believe this brand saturation may have influenced the modern English word fridge itself. That is the kind of cultural erasure only the largest corporation on Earth could engineer. From 1919 to 1979, Frigidaire was a General Motors property. The financial and political weight General Motors threw behind the electric compressor model was unlike anything a small Indiana manufacturer could withstand. Servel never held more than 8 to 10% of the home refrigerator market despite building a better product. Then came rural electrification. Government programs strung copper wire and wooden poles into every corner of America through the 1940s and 50s. Each new electrical connection created a potential Frigidaire customer and eliminated one more reason to buy a Servel. The grid itself became a nationwide sales pipeline for compressor refrigerators. By the early 1950s, the walls had closed in completely. Electric refrigerators were cheaper to mass produce. Federal financing programs favored them. The electrical grid now stretched to nearly every farmhouse and cabin. Advertising had convinced an entire generation that gas meant primitive and electric meant progress. Servel manufactured its final refrigerator in 1956. The Evansville factory went dark. The city was devastated. 28 new businesses had to relocate to the area from 1955 to 1963 just to prevent a total economic collapse. Whirlpool eventually purchased the empty Servel plant in 1958. They closed that facility too in 2010 and shipped the jobs to Mexico. A machine with no moving parts, a 50-year lifespan, complete independence from the electrical grid. It did not fail, it was killed, because a product that never breaks and never needs electricity generates almost no recurring revenue for anyone. Here is the bitter part nobody talks about. The compound that replaced the gas refrigerator nearly destroyed the planet's atmosphere. Freon seemed miraculous in 1930. Thomas Midgley died in 1944, 3 full decades before scientists discovered what his invention was doing to the stratosphere. The ozone hole above Antarctica became one of the defining environmental crises of the 20th century. The Montreal Protocol was signed by every nation on Earth to phase out the chemical that had once extinguished a candle and launched a trillion-dollar industry. Meanwhile, ammonia, the working fluid in every absorption refrigerator since 1858, harms no ozone, traps no heat, and breaks down harmlessly in the atmosphere. The supposedly primitive technology was the responsible choice from the very beginning. But the consequences reach far beyond chemistry. The world standardized on a refrigerator that demands a stable electrical grid. Then it failed to provide that grid to billions of people. Today, roughly 2 billion people across the globe lack reliable refrigeration. Approximately 1.1 billion of the poorest people alive have zero access to electricity. Families in sub-Saharan Africa watch food spoil in the heat. Villages across South Asia are unable to store vaccines. In communities in Central America, children die from diseases that cold storage could prevent. This crisis persists in a world where a refrigerator that runs on a candle flame was invented over a century ago, perfected by Albert Einstein himself, and deliberately shelved because it could not generate sufficient profit for a car company in Detroit. Not everyone forgot. Some people never stopped using the physics that the rest of the world abandoned. In the rolling farmlands of Pennsylvania and Ohio, Amish families open their kitchen refrigerators every morning. No electrical cord runs to the wall. A small propane flame flickers behind the lower panel. These communities rejected the electrical grid for religious reasons, and in doing so, accidentally preserved a technology the rest of America was told to forget. The original Servel brand was eventually sold through Electrolux to the Dometic Corporation of Sweden. Dometic still manufactures absorption refrigerators today. The fundamental design remains the Platen Munters system from 1922, more than a century of continuous production. Modern propane units can run non-stop for 11 straight days on a single 20-pound tank. Off-grid cabins in Alaska, sailboats crossing the Atlantic, homesteads in the Colorado mountains, anywhere the grid cannot reach, the gas refrigerator quietly endures. But the real resurgence is happening inside university laboratories. In 2005, a research team at the University of Oldenburg in Germany built a working model to Einstein and Szilard's exact 1930 specifications. They machined the components, sealed the system, and lit the flame. The inner chamber dropped to 0 degrees Celsius. The design that no American corporation would touch in 1931 performed exactly as the patent drawings predicted it would. 3 years later, in 2008, engineers at Oxford University in England revived the Einstein-Szilard refrigerator as part of a research program to bring cooling to rural communities without electricity. The Oxford team concluded that modern materials and precision manufacturing could quadruple the efficiency of the original Einstein-Szilard design, 4 times the cooling from the same small flame. A company called Solar Polar in the United Kingdom has gone even further. They developed a low-cost, off-grid cooling system powered entirely by sunlight. No electricity, no water supply, just solar thermal energy driving an ammonia diffusion absorption cycle. The same chemistry that Ferdinand Carré demonstrated in 1858 is now being powered by the sun itself. Researchers in the field describe diffusion absorption refrigeration as one of the most promising technologies for cold chain services in off-grid regions worldwide. The physics that cooled American kitchens for 30 years is being reborn in laboratories from Oxford to Oldenburg to rural clinics across the developing world. The question now is whether you understand what was taken from you and what still remains available: a small flame, a sealed loop of ammonia, water, and hydrogen gas, no compressor humming on your kitchen floor, no electricity meter spinning on your wall, no moving parts to wear out and replace. This technology is older than the light bulb. It was observed in a London laboratory in 1824, commercialized by a French engineer in 1858, perfected by 2 Swedish students in 1922, validated by Albert Einstein in 1930, manufactured for 3 decades in Evansville, Indiana, then systematically erased by the most powerful industrial corporation in human history, not because it failed, because it worked too well to be profitable. The physics does not care about corporate strategy. It does not care about federal financing programs or billion-dollar marketing campaigns or lobbyists walking the hallways of Washington. Ammonia still evaporates in the presence of hydrogen gas. Evaporation still absorbs heat. A flame still drives the cycle. These are facts as permanent as gravity itself. Propane absorption refrigerators are commercially available right now. Dometic manufactures them in Sweden. Warehouse Appliance sells them across the United States. Plans for simplified versions sit in engineering libraries and online forums and in 45 patent filings bearing the signature of Albert Einstein. Every year, the electrical grid grows more fragile. Every summer, the blackouts stretch longer. Every hurricane season, more families watch everything in their freezers thaw and rot while they wait for a power company to restore service. And all this time, a technology that runs on a candle flame and lasts 50 years has been sitting on a shelf, waiting for someone to remember it exists. The flame has been waiting. It has always been waiting. Don't forget, if you want to take your off-grid electrical game to the next level, my buddy Oliver over at Off Grid Ohms with Oliver has got you covered. Go show him some love.